into 2x. No, let me change that. So I have y equal to x squared plus 4 raised to the power minus 2. What is divide the x?
See.
Divide the x should be, I'll use this minus 2 to multiply this 3, minus 2, multiply 3, multiply these brackets. What is the derivative of the bracket? If you differentiate this bracket, what do you get? What is divide the x of? What is divide the x of x plus 4? Is what? Is 2x. Okay, what is divide the x of x squared? Is what?
2x.
2x. So this 4 is a constant. Divide the x of 4 is just 0 because there's no x here, isn't it? So
Yes,
everything here is just 2x, but this 4 is 0. So use this minus 2 to multiply 3, then multiply by the derivative of the bracket, which is 2x, then multiply by the bracket itself, x squared plus 4, raised to the power minus 2 minus 1. That power minus 1 is what? Minus 3, isn't it?
yes.
Do you agree with me? So it becomes minus 3. Final answer becomes minus 6, no, minus 12x into x squared plus 4 raised to the power minus 3. So I'm just trying to ensure that the the x is okay. Now, one more thing. What is the derivative? This is the derivative. Huh? Say what?
So where did the minus 3 come from? Oh,
Now,
minus 1. Okay, no, it's fine. It's fine.
minus 2 minus 1 is minus 3.
Yes, sir.
Okay, let's say that, let me change that this, let's say this power is not minus 3. Okay? Let's say that this, let's say the power is, let me go and change, okay. Let me change everything.
Yes.
Let's say the power is 5. What will be our derivative? It becomes, so I will then say that this 5 times 3. 5 times 3 multiplied by the bracket derivative is what?
It's
2x multiplied by the bracket x squared plus 4 raised to the power. What is, in this case, is now 5 minus 1, right?
yes, 4.
So 5 minus 1 is 4. So raised to the power 4. Our final answer will now be 30x into x squared plus 4 raised to the power 4. So what if I want to find derivative of sine 2x? Is what? What is derivative of sine x?
Is it sine?
Derivative of sine x is cos x. So to solve this one, chain rule, differentiate the brackets. These 2x, find derivative of 2x, it is 2. So I'll say 2 multiply cos 2x. Chain rule.
Is that
Okay?
effect, like, is that effect that derivative of sine x is cos x?
Yes. The derivative of sine x is cos x. So okay, let me even, I think I need to touch this a little bit. Let me just show you the process briefly before we move on.
Yes.
Now, I want to find derivative of sine 2x. Okay, sorry. Now, to solve this, I will let 2x be equal to u. So what is, sorry, let me write it the other way. Let's u equal to 2x. So the x becomes what? Becomes what?
It becomes 2.
2. Okay, let me start by saying that you y is equal to sine 2x. Okay?
Yes.
Then I want to find find the y, the x. So I'll first of all let this 2x equal to something. So u equal to 2x. Then I will do the x is 2, isn't it?
Yes, sir.
Therefore, y equal to sine u, right?
Yes, sir.
So I'm looking for the u, the x, but first of all, let me do the y, the u. In this case now, y is with respect to u, not x. So if I want to differentiate this one now, I'll be having, hold on, if I differentiate it, I'll have the y, the u, not the x now. The y, the u is what? Cos u, right?
Yes.
And cos u is equal to cos 2x. So the y, the x is the y, the u. Okay, let me write the other one first. I'm coming. Equal to the u, the x times the y, the u. Do you agree with this formula? Have you seen it before? What's this formula called?
Chain rule.
Chain rule. This is called chain rule. Now that means that the y up, the x down. This du up can seem to be like it is cancelling, but not actually cancelling, but as well as cancelling. So du dx, what is du dx? 2. 2 times y du is cos 2x, which is 2 cos 2x, right? So this is a
So
brief revision. So what?
I'm lost.
Okay. Okay, let's do another one together from the beginning.
So may you please start from where it says y is equals to sine u, right? U.
Okay.
Yes, sir.
Actually, this is not right to, it is with respect to, with
Oh,
respect.
with respect. Okay.
Okay.
Oh,
It's not right to just say that since, okay, what I mean is that assuming this is y equal to sine k, then I'll do the y, the k is cos k.
okay. Yes, sir.
So this k will be what will be under. So that means that if I differentiate this one, I'll not be doing the y the x, I'll be doing the y the u. That's why I'm writing the y the u.
Okay. Yes, sir.
So but we're looking for the y the x, right?
Yes.
That's why I'm going to use this chain rule. So the u the x times divide the u. Okay? That's the reason.
And then you said dy du is equals to cos u because you said sine x. That
Because y is sine u. So divide the u will cos u. If this thing is m, it will be cos m. If it is g, it will be cos g. So first of all, the formula is this. The formula of divide the x is du dx times dy du. So you have to look for du dx, look for divide the u. And then that's why I look for du dx. Then I look for divide the u. You know what?
so we have du dx and
Divide the u. Let's just do one more. Let's just do one more. Let's say we
where did you
have,
get the dy du from?
I need divide the u because I have to apply chain rule. There are two
Oh,
functions here.
cos u.
There is sine function and there is algebraic function. So I have to use chain rule. So let
Yes.
us do one more before we move on to the integration.
Yes.
Now, y equal to, let me say, let me see you sine 3x squared. Now, don't forget that the y, the x, this is going to involve chain rule because the function, first function is sine of angle, right? Sine theta. And then we have 3x squared. So if this one is f of x equal to this, and this one is g of x, that means, sorry, let me write that again. If this first one is f of x, and this one is g of x, then this one here It's like saying that f of g of x function, okay, composite function. So when you have something like this, you have to do chain rule. When you have two functions inside the question, you have sine angle and you have function of angle. The angle is another function of itself. When you have two functions like that, you have to do chain rule. So since I know that my question will involve chain rule, then I'll write somewhere the formula for chain rule. Chain rule is I'm looking for the y, the x, but I'm going to let u equal to something. So that means I must do the y, the u, because that du also have its own derivative with x multiply. So du dx times the y du is my dy dx. So they're saying that a over c is a over b times b over c. Is that c this b, you cancel this b, right? Isn't it?
Yes, sir.
Hello?
Yes.
So it looks
Yes.
like they're canceling, but they're not actually canceling. But it looks like they are canceling. So you can see that you can have a over c here, right? So that is how we arrange the chain rule the calculation. So dy dx is du dx times dy du. Sorry, let me write that again. It is the u and dy du. As if this du and this du we cancel out, right? So now that I've written my formula for chain rule somewhere, I can now go ahead and solve that function. So I can now say, that I can let u to be equal to, now, what, let u equal to what now? Can you try? Let u equal to what? Hello?
To 3x.
Huh? 3x what?
Squared.
3x squared. So now, if I now find the derivative of u, it will be with respect to what variable now? Huh?
Yes, sir.
U is with respect to what? Which variable? Is it like, can I say du dm or du dy?
Du dy.
No.
No, du dx.
Because, thank you, because in a function of u, x is the variable, right?
Yes.
So I'll be doing du dx. So what is du dx?
It's
The power multiplied by the coefficients. 2 times 6, 3 is what? 6.
x.
Then that variable x raised to the power.
The
Reduce the
differentiation
power
of
by 1. Yes. 2 minus 1 is what? 1, right? So power 1.
Yes.
So I'll leave it at that. So just power 1. So now to move on from here, then I'll now say that if u equal to this, therefore y should be sine what? Sine u, right?
Yes.
Good. So don't forget that you have got the u dx. Let's keep it. Now y is sine u, then the y, the what now? The y, the what?
dy dy du.
Yes, because right now y doesn't have function of x for now. Y has function of u. So the y du equal to what?
Dy du is equals to u,
It's not
which is
u.
equals to 0.
What is the derivative of sine function?
Cos.
Cos. So the y the u should be cos u. Okay?
Oh, yes, sir.
Yes. Now, but u has a value, right? U is 3x squared, isn't it? So let's say
Yes.
that means that this is cos 3x squared. Okay? So at this point, you can now find the y dx, which is I can write it as the y du multiplied by the u dx, isn't it? Right?
Dy
Hello?
dx is equal to y
dy du times du dx. Now, can see that there is du down, there is du up, right?
Yes.
It's as if you can cancel out. By the time I cancel the number, don't I have dy over dx? Don't I have dy over dx?
Yes.
Huh?
dy,
Good.
yes, dy
Yes.
over dx.
But I'm not going to cancel it because each of them has value that I want to use. So I'm not going to cancel out. So, and again, I prefer writing the du dx before writing dy dx. So I'm going to write du dx first. Du dx multiplied by dy du. Can I say that as if du will cancel the u, but I won't cancel out because du has a value. What is du? Du dx is what? 6x. That is 6x multiplied by divide the u, which is this, cos 3x squared. That gives the answer to be 6x cos 3x squared. So we'll suspend the differentiation topic here, except we want us to go over it. So we're going to go into the integration now, right? Is that okay by you?
Yes.
Okay.
So now, I don't think I can say I fully understand.
Differentiation, right?
Yes, sir.
Okay. So maybe later on we can go by it again.
Okay.
Or let us since we want integration so bad, let us start with it. So later on we can go back to it. Okay. Now, if we want to start the integration, then there's a table for the differentiation. Let us at least write the table out. Yes. So the table for the differentiation, we have f of x. Or let me see y equal to f of x. And then you can have the dy dx. Yeah. So if you have something like a f is power n, this is general formula for the algebra, right? Yeah. N times a, n multiply a, although mathematically that is poorly arranged, should be a multiply n, alphabetical order, x to the power n minus 1. So if you have sine x, then divide x is what? Cos x. If you have cos x, don't forget that I said that if you have y sine x, the derivative is cos x, right?
Yes.
But if you have cos x, what is the derivative of cos x?
Sin x.
It's not sin x, but you are close, very close. You are very, very close. Try again.
Cosecant.
No, it is negative sine x. Okay, negative sine x. So if you have tan x, what is the derivative of tan x? It is sec square x. Sec square x. So if you have something like,
so, but are we required to know the derivative of 10x?
Okay, you don't know it, right?
Yes. No, like my teacher taught me, but then I had people saying it's not there in the syllabus. But my teacher taught me.
Oh, it's not in your syllabus. Okay, but
yes, I think it's for A2.
Okay, but it's good to know. Just take note of it. So if you are doing it in A2, we are always here to assist you out. Okay, so don't worry, you are covered. So now tan x is sec square x. What if you have sec x? Okay, if you don't have tan x in the syllabus, that means you won't have sec x. But the derivative is sec x times tan x. I'm using dots for times for now, okay? For this kind of, when I'm doing something like this, I put dot for times. Then, if you have cosec, do you know that, what is sec? Do you know what is sec, first of all? Sec sec x is the reciprocal of cos x. Do you remember?
Yes, sir.
And then cosec x is the reciprocal of what? Sin x.
Same.
And then the reciprocal of tan x is what? Cos. Cos x. Cos x. So cosec x is what? Minus cosec x times cos x. If you have cos x, derivative is minus cosec x. Okay, let me just put them together. Okay. Now, if you have ln x, do you know what ln is?
No, sir.
Ln is log. Okay, have you done? Did you do logarithm in this AS?
No, sir.
Okay. All right. Is logarithm supposed to be in yours? Okay, it's in A2. Logarithm is in A2. Okay.
Yes.
In that case, we will not need this link for now, but let me just show you. When you have logarithm, then when the log normally natural the general log is base 10. But when you have log to base e or maybe x, then you have ln x. To differentiate ln x, you have 1 over x. I'm going to stop here. Okay?
Yes.
So
Yes,
so we'll be referencing this formula, this relation. This is like a brief summary of differentiation. This is the brief summary of divide
yes.
x. Although there are more than this, but at least this is a good guide. So now, on that note, I want to do integration.
Yes.
What this summary means is that I'm coming. Okay, from this summary. Okay, I'm coming. It means that if I integrate cos x, I'll get sin x. Okay?
Yes, sir.
So if I integrate divide the x, I'll get sin x back. If I integrate minus sin x, I'll get cos x. Or if I integrate sin x, I'll get negative cos x. Okay? That's what I mean. So now let us look at integration. And then don't forget that, let's say you have y, let's say you have y equal to let me say 3x squared plus 5x plus 4. Then the y, the x is what? 2 times 3, 6x plus 5, isn't it? Isn't it?
Yes, sir. Plus 5 plus 0.
Yes, plus 0. It becomes 0. Now, if I want to now, so let's say that this one has turned to 0. We are not writing it anymore. No more. Then we want to integrate. Let's say this is one question. Then later on, we want to integrate 6x plus 5. X. Want to integrate this? This.
It will be. Oh, okay.
Okay. I'll come back to this. I'll come back to this. I'll come back to all this. Don't worry.
6x
Let me
squared.
introduce this. Okay, let me just start the topic first. I'll come back to that. Now, for integration, if y equal to ax raised to power n, integral y dx is what? First of all,
Is ANX n plus 1.
Power. Ax raised to power what?
And
Come again.
it's AX n, then n plus 1. Plus 1.
N plus 1. Good. Then what else?
Yes.
What else?
Plus
Divided by
C.
something. No.
Oh,
That,
divided by n plus 1.
N plus 1. Good.
Yes.
So the plus C is because of that constant that we. Hello? Say what?
Say, aren't you supposed to multiply the AX by n again?
You're supposed to divide. No, you're not supposed to multiply by n again. No. Instead of multiplying, you divide. Remember that when we did, if you are differentiating, you multiply by that n times a, right? So the answer derivative is the opposite. You will divide. So instead of n minus 1, we're going to do n plus 1.
Okay.
N plus 1. And instead of multiplying by n, we're going to divide by n plus 1. So in this case, in derivative, you first of all multiply by n, isn't it? Multiply by n first before you change power, right?
Yes.
But in integration, you will change power first, and then you divide by n plus 1. You increase power first to n plus 1, and then divide. That is integration. Okay, now let us look at some. I'll be following the question in the textbook. Or okay. Now let us try one or two. Let's look at exercise 10.1. If I want to integrate 2x, exercise 10.1, number 1, I want to integrate 2x. Now, if you are integrating, mostly you like to write the if they put integration sign, they must put the x in front of it. Okay, the culture in integration. So if you integrate 2x, what will it be?
It will be 2x. No, wait.
2x. What's power what? The power here.
The power 1.
The power here is what? 1, right?
1,
Is
2, x squared.
So it becomes 1 plus 1 all over 1 plus 1, then plus c, isn't it?
Yes.
And then it becomes 2 raised to the power 2 x raised to the power 2 over 2. This cancels this plus c becomes x squared plus c. True or false?
Yes. It's
Then
true.
over 2, let's do, want to integrate x raised to the power 7 dx. What will it be?
It will be x to the power 8 over 8.
Yeah. Plus what?
Plus c.
Plus the arbitrary constant plus c. Now, let's say you have something like number 3. Why I want to integrate 10x plus 8x to the power, okay, let's say 7. Let me say 8 to the power 5. What will it be?
It will be 10x squared over 2 plus
okay, they put 7. Let me put 7. Since they put the question says sorry. The question says 7. Let me put 7. There's a reason there. So 7 here. This one is 2. Good. Then this one becomes what?
Which one? Oh, it becomes
now,
8.
8 what?
It becomes 8x to the power 8 over 8.
Over 8. So this cancel this. 2 cancel 10, the remaining 5, right? 5x squared plus x to the power 8.
Yes.
Okay? If you like, you can factorize this. X squared is common. X squared into 5 plus x to the power what? 6. You have removed x squared. So 8 minus 2 is 6. If you like, this is not compulsory, okay? You can leave it like this. Now, if you have number 4, you have, okay. If you have integral x into x to the power 4 minus 6, what do you do?
Becomes x over.
Now, can you see that there is x outside the bracket, right?
Yes.
That means that this x will multiply into the bracket. Okay? So if this kind of question, it is best you expand the brackets. If you expand these brackets, it will become difficult for you to solve. So expand the bracket. So x times x to the power 4 becomes what? X.
Wait, say. What's the
x power 4? Huh?
Was the x there, like, in the question?
Yes, it's in the question. Look, I'm solving h. This one. Can you see this question? It's in the question x into
Oh,
x to the
okay.
power 4 minus 6.
Oh, okay, yes.
So what do you do? So multiply this x, multiply each of them. X times x to the power 4 becomes what?
X to the power 5. X to the power 5.
X power what? Huh?
5.
5, good. So this is x. So you're integrating x to the power 5 minus x times 6 is what?
6x.
6x.
Yes.
Dx. So if you integrate this one, what will you get? X to the power 5, what will you get?
If you integrate what x to the power 5, you get x to the power 6 over 6.
Over 6 minus what?
Minus 6x squared over 2.
X squared over 2 plus what? Oh, we did not have plus 6 things. We didn't have plus 6, plus C here. Plus C. So plus C equal to, so that will give us x to the power 6 over 6 minus 3x squared plus C. Now, let's say you have number 5. You want to integrate 2x squared plus 7x over x. What do you do? If x is dividing, if this number 4, x is multiplying now, x is dividing, what do you do?
Oh, okay, so in the denominator, becomes x to the power -1. So when we're integrating that x,
the best thing to do is, since the denominator is just a function, just one, you can divide into the numerator. So you can use that denominator to divide the numerator. So it can become integral 2x squared over x plus 7x over x dx.
yes.
Okay, does that make sense? So if you, now it becomes integral x dividing x squared is x, right? This becomes 2x. X dividing x is 1. This becomes 7 plus 7 dx. See? If you integrate it now, it becomes what? 2x squared over what?
Over 2.
Over 2 plus what?
Plus 7x.
Plus 7x plus c.
Yes.
That's all.
Yes.
Then you can now conclude it. X squared plus 7x plus c.
Plus c.
So now, let's say that the function is irrational. Like, let me say that I have number 6. Y is equal to the square root of x. How can I integrate it? How can I integrate this?
So I'd write it out in the form x, okay, integral x to the power 1 over 2 dx.
Thank you. X to the power 1 over 2 dx, right?
Yes.
So what will it become?
And then it becomes x, yeah, x to the power 1 over 1.
No. What is 1 over 2? You know, you have always add 1 to the power, right?
Oh,
What is 1 over 2?
I did 1.
Yeah, so you must add 1 to the power.
3 over 2. 3 over 2.
3 over 2. Then divided by what?
3 over 2.
3 over 2 plus c.
Yes.
This gives us what? X to the power 3 over 2. Now, this 3 over 2 is dividing, right? If I bring it to the numerator, I'll turn it upside down. Do you agree?
Yes.
Can I write like 2 over 3 multiplying x to the power 3 over 2?
Yes.
Good. Plus c equal to, this 2 under now is roots. This 3 is power. I can say 2 over 3 x raised to the power 3, then square root plus c. True or false? You agree, right? You can leave it like this. So this is the first concept of integration. Now, okay. Now, see that sometimes, look at this part, finding constant integration. Yeah. I'm listening. What you say? What?
I was saying, isn't you said that 2 is the root, right? If it was 3,
Yeah,
so it was going to be root.
I have x raised to the power 3 over 2. So
yes,
that means I can say x raised to the power 3 raised to the power half, right?
yes. Oh, okay.
This half is square root. That is the square root of x to the power 3. That's
Oh,
why I'm
but
writing this one.
yes. Let's say it was 5 over 3, right? It would be cube root.
Good. It will be cube root. Cube root of 5 is x to the power 5.
Yes.
Become cube root of x to the power 5. Good.
Yes, sir.
So moving on to the next part. Let's say that the question requires us to find that constant. Let's look at one or two. Now, this is example. Let's look at one or two questions. Now, find the equation of each curve, given divide x and a point on the curve. Okay. Now, you have number 7 question. The x is given as 3x squared minus 6x plus 2. Okay? This is the derivative of the curve. And then a point on the curve is minus 2, minus 10. That's the first question, right? Can you see the first question? Now, so this is the derivative, and this is a point on that curve. So to find the curve itself is y, isn't it?
Yes.
So y is now equal to the integral of 3x squared minus 6x plus 2. Want to integrate this? It becomes what?
6x. 6x
How do you get
to the power
6x?
3. 6x
It's
to the
not
power.
6x.
Oh, 3x to the power 3 over 3.
Good. 3x to the power 3 over 3 minus 6x to the power 2 over 2 plus 2x plus c, right? Isn't it?
Yes.
So y becomes this 3 cancel 3, x cubed minus 2 cancel 6, 3x squared plus 2x plus c. Now, after we have integrated, you apply the point. The point is minus 2, minus 10, isn't it? That means that when x is minus 2, y is minus 10, isn't it?
Yes.
So I will change, anywhere I see x, I put minus 2. And if I see y, I put minus 10. So this y becomes minus 10 equals to minus 2 raised to the power 3. Minus 3 into minus 2 raised to the power 2 plus 2 into minus 2 plus c. Consider that there's no unknown again except c, right?
Yes.
So minus 10 on the left is what? Minus 2 raised to the power 3. 2 raised to the power 3 is what? What is 2 raised to the power 3? Half 8, right?
8.
Is it 8? 8.
Yes, 8.
Now, will it be plus 8 or minus 8?
It's 8.
Will it be plus or minus?
Oh.
If you are doing instances of a number,
minus.
if the power is even number, the answer will always be positive. Even if the number is positive or negative, you The answer will be positive if it is even number. But if it is odd number index, your answer will be the same answer, will be the same sign with the question. So we do minus 2 raised to power 5 is going to be 32 because this 5 is odd number negative. Minus 2 raised to power 6 is going to be 64. No matter the sign, because this power is even number, be positive. Okay? So with this one, will it be positive 8 or minus 8? Will it be positive or negative?
Negative.
Negative. Good. Negative. To be negative 8. So negative 8. Now, this is minus 3. Minus 3 into minus 2 square is 4. Is it plus or minus 4?
It's plus.
Plus 4. Okay? Minus 2 times plus 2 times minus 2 is what? Minus 4, right? Plus
yes.
C. It is minus 10 is minus 8, minus 12, minus 4, plus C. This together will give us 20, 24, minus 24, minus 10, plus C. So C should be equal to minus 10, bring 24 across, become plus. So C is 14, isn't it?
Yes.
Therefore, the curve is y equal to x cubed minus 3x squared plus 2x plus 14, right?
Yes.
Isn't it? Good. So now note, you're going to solve, ouch. All these questions are okay. Now, the C question, what do you do first? You expand the bracket, right?
Yes.
So you have divide the x is x into 2x plus 5. Expand this bracket. After expanding the bracket, then you integrate. Then you put this point to get the value of C. So solve. Let me see you solve this one. 1C. Solve 1C.
1C.
Yes. 1C.
Okay. Two x to the power 3 over 3 plus 5x squared over 2.
Okay, that's integration, right? Plus C, isn't
yes.
it? Okay,
yes.
now put that point.
The point.
Put the point. Yes. And so that I can find the value of C.
Oh, it says that 5.21. Okay. So I'm getting a very funny answer.
Yeah, we're looking for it, right? It will be algebraic. It will be fractional.
Yes.
Just right.
Negative 313 over 3.
No, I don't think I'm not getting. I'm trying to solve it now, but I'm not getting what you're getting. Check again.
Okay.
So, did you see any error in your solution?
Yes, sir.
So, what's the mistake? Okay. Now, is it possible how can I see what you have done? Or not to tell me your final answer?
Now I'm getting negative at even worse, sir.
What is the constant? Tell me the constant. The arbitrary constant. What did you get?
Negative 2,300.
Okay. And that is even very large. That's larger than other. Okay, let us do it together. Let's do this together. So it says number 2, okay, 1C, y, the y dx is x into 2x plus 5. That
Yes.
is 2x squared plus 5x.
Plus 5.
Y is now the integral of 2x squared plus 5x, which is 2x to the power 3 over 3, right?
Yes.
Plus
5x
5
squared
squared over 2 plus what?
C.
Plus c, right? That is y.
Yes.
So at that point, the point is what? 5 comma minus 1. So y is minus 1, x is 5, right?
Yes.
So when y is minus 1, 2 into x is 5. 5
Yes.
cubed
To the power 3 over 3.
over 3 plus 5 into 5
5.
square over 2 plus c. Minus
Yes.
1 equal to 5 cubed is 125
125.
times 2.
Yes.
Times 2 is
250.
250 over 3
Yes.
plus 5 square is 25 times 5, 125 over 2 plus c. I'll take this 2 to go and make minus 1. Minus 1 minus 250 over 3 minus 125 over 2 is c. So I can only add them together when the denominators are the same. So let me make sure that denominators are the same. So this one is like saying 1 over 1. So the LCM of 3 and 2 is what? 6, right?
Yes.
Do you agree?
Yes.
So this is like 1 over 1. So I will now say that LCM divided by denominator times numerator. 6 divided by 1 is 6. 6 minus 6 is 3 minus 6. 6 divided by 3 is 2 times minus 250 is
500.
now minus, huh?
500. Minus
500.
500.
Good. 6 divided by 2 is 3. 3 times 125 is 375. Negative 375 is equal to C. So C will become minus 500 minus 375 is minus 875. Then minus 6 will become minus 881. So minus 881 over 6. I can leave like this because 6 cannot divide 881 without giving the remainder. So leave it like that. Therefore, y becomes 2x cubed over 3 plus 5x squared over 2 minus 881 over 6. That will be our final answer. Now, if you have to do, look at that. Okay, I believe you can do, okay, let me see. Okay. Okay, look at this number 8. This is number 8.
Okay.
Okay, let me see number 8. Okay, sorry, do number, I'm coming. I want someone to, the one that is not too, okay, do number 5. Number 5. No, sorry, it's second derivative. Leave that. The second derivative, I don't want to do something that is too critical, okay? Okay, just do number 1e. This one, do number 1e.
Okay.
So that means that you will divide first, isn't it? This x will divide both of them first. True or false? You agree, right?
Yes, sir.
Okay. Any answer?
Okay.
Are you done?
No, sir.
I want to ask, have you attended a lecture in integration before?
Yes, sir.
Okay. What topic? Did you get to the end of the topic?
Yes, sir.
Okay. So it's like we are revising this topic, right?
No, sir.
Okay. Okay. All right. So we're taking it, that means we're taking it afresh from the beginning, right?
Yes, sir.
Okay. All right. No problem.
364.
So, good. That is your constant, isn't it?
Yes, sir.
Good. All right. Let us look at. Okay. Now, some, I just said, any questions can look like this number 10. Can you see this number 10?
Yes.
It's a curve that is passing through. They are giving us 3 points that the curve passes through, right?
Yes.
And then the derivative has no number, just ax plus b. How do you solve this? Can you give it a try?
Yes, sir.
Now, make an attempt first.
Yes.
Let me see what you're going to do.
Okay. Is it find the equation of the curve? Find the equation of.
Yeah. Now okay. You know what? Okay. You know what? I want to look through this question. The next, I want to try it. Then, because okay, Okay, do you think we should keep this one till next class, or should we do it quickly? Should we just do it now? I'd love to give you to do it at your leisure, but if you want to solve it now, we can solve it now. Number 10. Should we solve it now?
So let me do it first. Let me do it first.
Okay. Okay, good.
Yeah. Let me try it first.
Right.
Say, never mind. We can do it.
Okay. And let's do it together.
Yes, sir.
So the question says.
But do we differentiate?
Yes, it is differentiated. You're going to integrate. This is the y, the x. So integrate. You have the y, the x is ax plus b. So when you integrate it, y becomes the integral of ax plus b. So what is the integral of ax plus b? So
it's ax squared over 2.
Yes, plus what?
B squared over 2.
No, just bx.
Oh, bx, yes.
Plus what?
Plus c.
Plus c. Now this is y. Then you'll be applying each of the points. The first point at 0, 0. That means x is 0, y is 0. So I will say that 0 equal to a into x is 0 squared over 2 plus b into 0 plus c. 0 equal to 0 plus 0 plus c. That means c is 0, right? Isn't it?
Yes.
That means that y equal to ax squared over 2 plus bx plus 0. That's good. Then the next point at 1, 1. At 1, 1. You have y is 1. So you're going to use, you don't want to use this one anymore. So you want to use this one. A into 1 squared over 2 plus b into 1. So you have 1 equal to a over 2 plus b. I can multiply this by 2 and because of this over 2, I don't want to have fraction. To multiply left and right by 2. 1 times 2 is 2. A over 2 times 2 is a. B times 2 is 2b. Let me call this one equation because I'm going to get something else for the second one, for the next one. At the point minus 2, 16. Now, at that point, you have y is 16. So instead of, in place of y, I will put 16 equal to a multiply x is minus 2 squared over 2 plus bx become b into minus 2. So 16 equal to a square minus 2 square is 4 divided by 2, that's 2. So 2a plus minus b. So b times minus 2 is minus b. So that is minus b. Equation 2. So I've now taken this equation together and sum them. So if you have, now I want to make one of the variables to be the same. This becomes what? When I have these two equations, what kind of topic, what is this topic called now? When I have two equations, two variables.
Equations.
Simultaneous equation. So yes. I can solve for A and equate to the other one, right?
Yes.
Okay, now let me solve for A. From equation 1. Okay, you know what? Finish it up and tell me the value of A and B.
Okay.
Yeah. Sorry. Sorry, there's a mistake somewhere. Sorry. This one here is not minus b, it is minus 2b. This b times minus 2 is minus 2b. Right? This is minus 2b.
Oh, yes, minus 2. Okay. Yes.
Sorry about that.
B is equals to 9.
B equals to what?
9.
10. Did you say 10 or 9?
9.
Okay. What of A? What is A?
Negative 16.
Okay, I'm not sure. He said that one of us is, I got B equal to minus 2, A equal to 6. So one of us is wrong. He said that you are wrong or I am wrong. Should we do it together to know who is right?
Yes.
Should we do it? But okay. Now, from equation 1, I will solve for A. I have 2 equal to A plus 2B. So I'll take this 2B across. So 2 minus 2B is equal to A.
Yes.
So now put this value for A in equation 2. Substitute for A in equation 2. Equation 2 is 16 equal to 2A minus 2B. So that is 16 equal to 2 into the previous value of A, 2 minus 2B, then minus 2B, right? Minus 2B. So let me scroll up.
Let's add the minus 2.
Have you seen any error being made?
Yes.
All right, 16 equal to 2 times 2, 4. Minus 2 times minus 2, that's minus 4 b. Then minus 2b. So that is 16 minus 4 is minus 2b, minus 4 minus 2 is minus 6, isn't it?
Yes.
So this is 12 equal to minus 6b. B must be 12 over minus 6. So b is minus 2.
Yes.
And I put this value back into A. A is 2 minus 2 into B, right?
Yeah.
Into minus 2. A has to be 2 plus 2 times 2 is 4. Minus minus is plus. So A must be 6. Now, therefore, now we got our equation to be ax squared plus bx plus c. Now, so y is ax squared over 2, right? Over 2, isn't it? Over
Yes.
2. Good. Plus bx plus c. Plus bx plus c. Y equal to a is 6, then x squared over 2, plus b is minus 2. Minus 2x, c is 0. So y equal to 3x squared minus 2x. That's all. Okay, so that's the application. Now, before we leave, that's the now if it's something like d square y over the x square, what does that mean?
It means it's the, what is it called? Second derivative.
Second derivative. That means the dy dx of dy dx, or d dx of dy dx. Second derivative. So when you do it first time, now do it second time, right?
Yes. Yes.
Okay. So now integrating expressions in the form of that. Now I want to integrate something that look like this. Now, when you have something like this, the best thing to, okay, what we now, what you can do is to use chain rule. You can use what? Chain rule. Now, you can use the chain rule in integration. Let me say, if you have integrating y equal to ax plus b raised to power n. So example, let us look at one or two examples. Now, no, I don't want to. Okay, look at this example now. Yes. One way is to expand these brackets. Okay, look at the general formula. Ax plus b raised to power n. If you integrate it, you will be dividing. Now, the increased power, look at this power n is increased to what? N plus 1, isn't it?
Yes.
Do you have soft copy of this textbook? Do you have soft copy of this textbook? Do you have soft copy of AS textbook?
Do I have what?
The soft copy of your textbook.
Of this textbook?
Yes.
No.
Okay. Now, before we do this one, let's look at the derivative that we did the other time. Notice that if you are integrating, I divided by the n plus 1, right? That's how I divided by n plus 1. But this ax plus b is the function itself, right?
Yes.
Then they divide by, then you see that function. Now, this power x n plus 1 is on x alone, right?
Yes.
But in this case, it's on ax plus b. So you have something like a chain rule here. So I'm going to differentiate the brackets. Now, when we differentiate the bracket in the other one, let me see if I can remember the question. Okay. Now, when I differentiated the bracket here, I multiply it, isn't it? Where is it?
Yes.
Oh, sorry, I have erased it by mistake. So this is 2x multiplying x squared plus 4. So when I differentiate the bracket, I multiplied it. This is derivative of the bracket, right? But in this case, they are dividing the bracket by its derivative. Here they're multiplying it. Here they're dividing it. So this a is the derivative of the bracket, right?
Yes.
Good. And then they'll now divide by this n plus 1.
Yes, sir.
So let's just first start from this example. Now, if you have y equal to 4x minus 3, oh, sorry, okay, raised to power 5, you want to solve this, want to integrate it, you can let u equal to 4x minus 3. Okay?
Yes.
Let me write that here. I don't want to do it cut the way they do it. I want to understand the chain rule. Let u equal to that bracket 4x minus 3. So anytime you let u equal to something, what do you do next? If you let equal to the function inside and the internal function, what do you do next? You find the u, the x. True or false? Huh?
It's true.
So
sir.
what is du dx?
Du dx is 4.
4. So this is the derivative of the bracket. That is the derivative of the brackets.
Yes.
Then I will replace this dx. Okay, therefore, y is equal to what? Integral u raised to power 5, isn't it?
Yes.
Do you agree with this?
Yes.
Because the entire bracket is y, is u. So, should I still write dx? Can I still use dx?
Say.
No. Can I still use dx?
Yes.
No, I can't.
Yes.
I can't use the x. I cannot. Do you know why? I can't use the x because this variable is u, not x.
Oh, so wait, it's
So I'm going to solve for from here. If the u over the x is 4, I can multiply the x over the u is 1 over 4. So the x is now equal to the u going up the u over 4. Do you agree with that? Do you agree that I'll make, if I say make the x formula and substitute formula, I can have the u over 4. Do you agree with that? Should we go over it again? Should we go over it again?
yes, sir. Yes, sir.
Okay.
Du over dx is equals to 4 dx over
Okay,
du.
let us
Yes.
do it. Okay, let us do it again. I have the u over the x is 4. I
Yes.
can cross multiply. So the
Yes.
u is 4 the x. So the u over 4 is the x. This is better, right?
Yes.
So since I've replaced this bracket with u, I'll replace this dx with the u over 4. So this is the u over 4. So this 4 can be outside 1 over 4 integral u raised to power 5 du. So which is equal to 1 over 4. What is the integral of u raised to power 5?
What's the integral of?
It is u raised to power 6 over what?
Over 6.
Over 6 plus c. So y equal to u raised to power 6 over, I have over 4 and I have over 6. They can multiply. 4 times 6 becomes what? 24 plus c. So y becomes, what is u? You said u is what? 4x minus 3, isn't it?
Yes.
Y is now 4x minus 3 raised to the power 6 over 24 plus c. The c will still be there because you've not applied for it. So that's why. Now, I don't want to do it this way because I want you to understand the chain rule. But you can still do it this way.
Yes.
So you know that there is not use the u, there is not let u equal to 4x minus 3. But before we look at this example, I want you to solve one or two questions first, then we come back to that. So solve number 1 with this method. Solve number 1a with this method. Then if you have understood that chain rule, then we can now go back to look at the way they solve it. That one is faster, but I want you to solve it normally first.
Yes, sir.
So solve number 1a. You want to still look at the example? We can look at it
No,
and
sir,
then
it's
solve
fine.
it. Is that?
No,
Solve
sir. I
it.
think
Solve your own.
yes, sir. Uh, okay.
What was your answer?
Say, I'm still working it out.
Okay.
Yes, sir. I got 2x minus 1 to the power 7 over 14 plus c.
Correct. Correct. So now that you understand, you apply this chain rule formula, right?
Yes, sir.
Good. So now let's look at the way they solve their own. Let's look at the first example. Now, what they did, they integrated it by saying that the bracket is 4x minus 3, right?
Yes.
The derivative is 4, isn't it?
The what?
The derivative of the bracket is 4.
Yes, sir. Yes.
If you have ddx of, let me change the thickness. If you have derivative of 4x minus 3, this one becomes 4, this one becomes 0. So they
Yes.
divide by that derivative, isn't it?
Yes.
Then that brackets raised to the power 5 plus 1, all over that 5 plus 1. 5 plus
Yes.
1 is 6. 6
6.
times 4 is 24, isn't it? So
Yes.
if you don't want to do this long method, they can do it this way. But the problem is that someone can easily make mistake doing this, unlike doing this, right? This
Yes.
one will involve you to do more calculation, but you will hardly make mistake in this method. So I want
With
to do
chain.
another question. Is that?
I'm saying with chain rule. So you
Yes,
recommend I'm using chain rule.
I recommend use chain rule. But
Okay.
if you are confident, if you have practiced some questions and you are good enough, but just use the chain rule because just use the chain
Okay.
rule.
Yes, I'll
For the
use.
for the exam coming, just use chain rule.
Okay.
Now let me see how you can solve Okay. So how do you solve number D?
D.
Yes.
Okay, let me do it. 3x plus.
Before we continue, I'd like you to have some questions for personal practice.
Yes, sir.
If you can you screenshot this page so that you can practice this on your own? Screenshot
Yes.
this question so you can solve from these ones.
Yes, sir.
Have you done that?
Yes, I've done that.
Yeah. So you can, because the class will be ending soon, so I want you to practice some of those questions before next
Okay.
class. So
Okay.
you are solved number D. Solve that D question. 1D integral 1 over. So let me ask you, what do you think you would do in this case? What are you doing? What do you think? What's the first step?
Let U equals to
If
3.
you do that, you'll be able to solve this question. That's not the first step. That will come. But what do you do first? If you are integrating one, now let's just, if you have 1 over A, it
A to the
become
power negative 1.
raised to the power minus 1, right?
Yes.
1 over A raised to the power 3 becomes A raised to the power minus what? 3. So do that
Yes.
to these brackets. Do that to these brackets.
It's going to be 3 to the power 5 minus 1.
3 plus 5, 3x plus 5. 3x plus 5 to the
3x plus
power
1.
minus 5 dx. So integrate now.
Okay. Write this down. 3x plus 5. So when I integrate it, I get no, see. Am I not supposed to differentiate first?
Okay. If you want to use chain rule, you let U equal to what?
Equals to 3x plus 5.
Okay. Or you know what? Leave chain rule. Do it the method that I did. Do this method so that this method can save time. I want to be sure that you can master it. So do this method.
Okay. Three x plus 5 to the power negative 4 over negative 12 plus c.
Okay, that's good. So you got so you got 3x plus 5 to the power negative 4 over negative 12 plus C, right?
Yes.
So is there something else can do here?
Yes.
Like in this case, when you have when
Yes.
it was in fraction form, they took it back down, right? Look at this example 7. Can you see example 7?
Yes.
After taking it up, solving it, they brought it back down. So how will you do that here?
Okay, so it will be 1 over negative 12 open brackets 3x plus
over negative 12 into bracket what?
3x plus 5 to the power 4.
To the power 4, right?
Yes.
Then plus C. But I'm not comfortable leaving negative in the denominator. So take the negative up. Minus 1 over 12 into 3x plus 5 to the power 4 plus C. Better, right?
So what did you?
Because we do
okay.
negative,
Yes.
just take negative up. Assuming this one is having negative also, then it will be plus. Okay?
Yes.
So because that one up is negative, is positive, then this becomes minus.
Okay.
So the answer will be left in this form. So now, this is the end of the class.